Okay, it looks like it might be recording. All right, so folks, practice problems for projectile motion. You notice this boy that is jumping off the rock ledge. Can you tell by looking at the diagram that he jumps mostly horizontal? Okay, so the horizontal motion is a constant kind of motion. The vertical motion is definitely accelerated. The color coding that I used yesterday was to show red was a horizontal motion. I'm going to draw a dot diagram here that shows that he is moving horizontally at a constant rate. And so if I were to place dots here showing how far he is moving horizontally, it should be constant. So that motion is constant velocity. The vertical motion is accelerated. So when he takes that jump off the ledge, he maintains his horizontal motion, and then as he's falling, he picks up vertical velocity. So that motion is two things at once. He can move horizontally while also accelerating vertically. The path that he takes, again, just like I showed yesterday, the path that he takes is more of a parabolic path. And so what we're interested in is figuring out how far he lands from the vertical ledge. Every projectile motion problem is the same, is that you separate out the two motions, here red and blue, and you link those two motions through a time variable. However long it takes for him to fall, that distance is the same amount of time as it takes for him to travel horizontally. So we just link those two motions through the time variable. Now you're going to be using the UAM equations twice, one for the red and one for the blue motion, and you link them through the time variable. So let's go ahead and switch this to blue. I notice that he's jumping from a 15-meter high ledge. So I'm going to make a little diagram here that says that the height that he's jumping from is 15 meters. And just for simplicity's sake, I'm going to call downward positive. I can choose any way I want to be positive, so I'm going to call downward positive. So delta y is a positive 15. The acceleration that way, I'm going to put a little subscript y is equal to g, which would be equal to 9.8 meters per second per second. So we know that he's accelerating downward. The sign of those two things would be important. His acceleration's in the same direction as his displacement. Now, I'm looking for the time it takes for him to fall. I'm going to put one more thing up here. I'm going to put a v initial. Can you tell by looking at that story problem what his initial velocity is? In the y direction. It's not 3.
0.
It's 0. And so I'm using blue for this. And that blue is to denote his vertical velocity. So I'm going to put v naught sub y. And that's 0 for this problem. It's not 3. That's his horizontal motion. Vertical motion is 0. So when I go to solve these problems, I'm putting now subscripts. Each one of those things that I have up there, equations that I have up there, have a subscript, x or y, to denote which way am I talking. Am I talking horizontal or am I talking vertical? Now I'm looking for the time that it takes for him to fall. I can put a subscript there if you want. You can put t sub y. What's the time it takes for him to fall vertically? By the way, delta y is a vector, a is a vector, and v naught is a vector. T is technically a scalar. So that y doesn't denote a direction. It's a scalar quantity. It has no direction. But that is the time it takes for him to fall 15 meters with no initial velocity. Now I would imagine at this point you guys are probably getting better with those equations, identifying which equation you could use to find time, knowing those things. Which equation over there might you go back to out of the ones from chapter 2? Thank you. Xavier has given me a sign there of 3, equation 3. Let's write it. Delta y is equal to v naught sub y times t plus 1/2 a in the y direction times t squared. Now when I go to write that, one of those terms is 0. So I don't even need to write it. I might just say delta y is just 1/2 a times t squared. Because this term here is 0 for this problem. So it just becomes delta y is 1/2 a t squared, and then solve that for t. I'm going to multiply both sides by 2. And then I'm going to divide both sides by a sub y. And when I'm done, I get an equation that looks like this. And that equation is the same equation that we solved, that we had to use for our just free fall stuff. And so I'm going a little bit faster through that now because we have practiced it some. Some of you are still developing on your skill set on using those equations. It's fine. There's nothing wrong with still developing. As you continue to work through these equations, you're going to get better and better and better at that. And then you're like, chapter 2, that was easy. You'll go back and you'll be able to do those things if you struggled with that first unit. Go ahead. I took the square root after. You good? Okay. Now I plug in some numbers and I can compute that. So 2 times 15, was it a 15 meter tall ledge? Divided by 9.8 meters per second squared. My calculator is going to give me that. So 30 divided by 10 is about 3. Take the square root, 1.7-ish. What is the number? 1.75. Okay. So 1.75 seconds. That's how long he's falling. How long is he moving horizontally? The exact same time. So now what I'm going to do is I'm going to switch that over to red, and I'm going to look at his horizontal motion. So again, the color coding is to help keep track of the fact that we have 2 different motions going on. Delta x is how far I'm looking for how far he's traveled this way. That depends on 2 things. How fast he's moving that way, and how long he's moving that way. Any acceleration in the x direction? See, speeding up or slowing down at all horizontally? So if you want, you could write a sub x is equal to 0. Often we don't do that just because we sort of understand that it's accelerating. But you notice I have the same kinds of things as I have here, but it's written in red because it's horizontal versus vertical. What equation might you use to determine how far he travels? Probably equation number 3 again. So equation number 3 again would be the equation. Notice I'm using x's now instead of y's. And again, some of you are going to be like, I don't want to have to write the 1/2 ax times t squared. That's fine. That term is 0. But I don't want you to think that we have all these new equations. It's the same equations, just with different starting values for each kind of quantity. Now this term is 0. I solve for delta x, and I just multiply the 3 meters per second multiplied by the 1.75 seconds. And that turns into, what, 5 1/4? Did I do that right? 5 1/4 meters is the distance that he travels. And that's how I solve horizontally launched projectile motion problems. Just it. You separate the 2 motions out, you link them through the time variable. I want to do a couple more with you. 2:30, we're in pretty good shape. We should be able to just get these 2 problems done and just sort of relax. It's a nice chilled day to get out of here. A stunt man jumps off a 25-meter ledge of a cliff horizontally. The rocks below extend outward from the base of the cliff a distance of 12 meters. So he's up there higher. 25 meters is pretty high up. 12 meters distance, he better jump with a decent amount of speed. We want to determine how fast he has to jump horizontally to achieve 13 meters. So 13 meter means he's going to get a meter of clearance so that he doesn't land right at the edge of the rocks. We're going to get out at about a meter further. You notice again the horizontal and vertical motion. So again, I use the dots to represent the different kinds of motion. Horizontally, he's moving at a constant rate, and vertically, he's picking up speed due to that influence of gravity. We combine those things to get the 2 motions, or the combined motion. Do you guys agree? I would use the exact same analysis to get the equation for the vertical direction. Good luck there, Dre. Hope it goes well. Do you guys agree I can go through the same logic that I had from the first problem that we looked at to solve that equation for time? As a matter of fact, you guys actually have it on the same page, right? The problem that you guys are solving right now is below the one that we just did. Say see above. It's the exact same analysis. The nice thing about solving things in letter form is that now I just plug in the different numbers for this problem. You guys see that? The nice thing about solving things with letters, not with numbers, is that I have a solution that can solve anything for any particular value of delta y. So plug it in. 2 times 25 divided by almost 10. So 2 times 25 meters, 9.8. My calculator would give me that more accurately. It's roughly the square root of 5-ish. 2 1/4, somewhere in that area. Two times 25 divided by 9.8 square root. Someone's going to do it for me. Thank you, Xavier. Just did that number in my head. I don't know if it's right. I remember that from the tower. 2.26 seconds. Longer in the air because he's higher up. Now I want to determine from how fast he has to jump. So I'm going to switch it over to red. He's got to clear a distance of 13 meters. He has 2.26 seconds to do that. And he's moving that way at a constant rate. There's no acceleration that way. So we want to determine how fast he has to jump. Exact same equation that we had from before. Delta x is equal to v naught times t. I'm looking for v naught, so I'm just going to go ahead and write that like so. He's got to travel 13 meters, and he's doing that in 2.26 seconds. And so that would give me the speed that he must jump horizontally. Okay? And if you can shout that out for me, that one I can't remember. 5.75 meters per second. So that would be the jump speed that he must have to clear those rocks. Okay? I got one more problem for you. Before we do it, I want you guys to sit in awe at my Photoshop expertise. You guys might not be able to tell that this picture is Photoshopped. So I looked all over the internet to find a picture of a hotel with a pool nearby, and I couldn't find it. So can you guys tell by looking at this that it's a Photoshop picture? No. You can't, I know, because it's really good. Just so you guys can see, that picture here is actually not a part. The pool picture is not a part of the hotel picture. So
you're joking.
I'm seriously, I photoshopped that. I'm so good.
I don't believe you.
This is fake. That water slide, that thing I think is real. All right. So a stuntman is going to jump off a hotel balcony into an in-ground pool. You see this in movies sometimes? They're like jumping there. They consult people. They say, what height, where do they have to jump from in order to land safely in the pool? I'm going to see if you guys can do this. If you ever need like a recommendation to get on as a physics consultant for a movie, you ask me for a letter of recommendation as long as you get this problem right. If the stuntman is able to jump with a horizontal velocity of 4.2 meters per second, and the pool is located 7 meters from the base of the hotel, I would like to know from what floor he needs to jump in order to make it safely into the pool. Now, that pool is 7 meters distant from the base of the hotel. He wants to get to an 8-meter distance so that he has a meter of clearance. Now, you guys can't, can you guys move that picture around on your diagram? You try zooming in on it, it doesn't work, right? So what you guys might do is you might draw off to this side, draw for me a picture. I'm going to do this in black. Draw for me a picture of all the things that we know, and then what do we not know, to try to figure out how we're going to approach this problem. So this is the pool, this is the hotel, and then you have a bunch of floors. On this drawing, what I'd ask you to do is try to make a sketch of things like where he's jumping from, what the path looks like, how far he's got to go. Just make a picture of those things, and see if we come up with the same picture. So you try it, and then look up here once you're done. How'd you do? Got a drawing that looks something like that? Probably don't have red and blue on there because you don't have the colors like I have up there, but the horizontal velocity is 4.2 meters per second. He's got to travel 8 meters. I would like to figure out from what height he has to jump. Now, when you see a problem like this, and you're like, well, hey, and the other problems I solved for time in the y direction because we knew the height that he was jumping from. I can't look in the y direction to determine the time. Which direction do I have to look at to determine the time? The x direction. So now I would look at this and say, well, I'm going to use the x direction stuff to find the time value. Time in the x is just v naught in the x. Sorry. Is equal to delta x divided by v naught in the x direction. He's got to travel 8 meters, and he's doing that at a rate of 4.2 meters per second. I think it's 1.9. Okay, 1.9 seconds is how long he's going to be in the air. Now I switched over to blue to determine the height from which he's got to drop from. And I just plug those numbers in to get that height. Okay, so 1/2, 9.8. That time is 1.9 seconds. I square that, and I get, if memory serves, I cannot do this math in my head, I get about 17.7 meters. That's what we're getting. Okay, so what I'm going to ask you to do is look at that problem. The producer, the director of the film comes to you and says, hey, Abby, you're the only one on our set that has ever taken any physics. And we need to know from what height we need to jump, what floor, sorry, he says what floor. He doesn't talk about height. He says, what floor does this person need to jump from? And so based on the information that you see here, he's got to travel 8 meters, he jumps at this speed, The floor, each floor is 3 meters high, tall. This room is about almost 3 meters tall, right? So this is like a standard hotel. From what floor must the stuntman jump in order to make it safely into the pool? I want you to turn and talk to that person that you're sitting next to and see if we can answer this question correctly so that I can write you a strong letter of recommendation to get on scene of a movie. Yeah, that's about 3 meters. Yeah, they gave us that. So, what would you say? The hotel or the movie producer, director comes to you and says, "What floor must you jump from?" And you would say, let's do a choral response. So that means we're going together. You would say, jump from floor 6. Oh my gosh, the person's going to smack into the concrete on the 6th floor.
Well, it depends where you start counting the floors.
Exactly. We live in the United States here.
This floor
You didn't say this was in Mexico?
No, this is in the United States. This is, Becca, you're from Italy? Oh. Becca, you're from Italy? In Italy, the what we call the 2nd floor is actually labeled what in a hotel for you? I think it's the 1st floor for you guys. The 2nd floor here is the one that starts 3 meters up. Would you guys agree? So, look at, you are thinking that 6 meters is not, or 6th floor. It's got to be the 7th floor. And the reason for that is that this is the 2nd floor, that's the 3rd floor, that's the 4th, that's the 5th, and that's the 6th. If you say it's the 6th floor, that's only 15 meters up. You would have to actually jump from the 7th floor. Now, would I put this question on a test or something like that to trick? No, but you would have to actually jump from floor 7 because we count these things in a really weird fashion. Okay. Make sense?
Yeah.
All right. Don't worry about the fact that it's the 7th floor, not the 6th floor. 17.7 meters is the height that they would have to fall from. Okay. Well, yeah, I do be in trouble with that one. All right, folks, I'm going to stop there. Let's do the